Hello and welcome to week 2 where we are looking at physical science. So our agenda for this lecture is looking at the components of physical science, then best practices, thinking about how to use inquiry-based learning, then looking at the NC standards, and then I'm actually going to give you a lesson example of physical science for 4th grade that I actually used in my classroom. So, first one is physical science components. So, thinking about your 3 main ones are matter, force and motion, and waves. So, matter, solid, liquids, and gas, physical and chemical changes, and law of conservation. All of these build on each other. So, in kindergarten, you will look at solid, liquids, and gases, and again in 5th grade and throughout, but they're building on each other. It's not the same exact thing of classifying them. They're more of what are the molecules, how do they look in 5th grade. Same thing with physical and chemical changes. You don't particularly use that language like in 3rd grade, but in 5th grade you will, and they will see that on the EOG. And same with law of conservation. That's a big word. They use that in 5th grade, but they talk about it in other grades. Same with force and motion. Start that in kindergarten. You talk about gravity, a push versus a pull, but even through 5th grade and on up, you still use those same vocabularies. It's just more application based. And then they also talk about velocity and graphs. So distance time graphs are huge in 5th grade. Then waves are sound, electromagnetic waves, and mechanical. And you use those throughout kindergarten and on. So really making sure that you understand the key vocabulary and the way that they will be assessed. So with that being said, especially 5th grade, because they do have an EOG, so I'm going to refer to that because that's where science is huge and very prevalent. But you don't want to just ask kids, what is gravity? You want to use it more in an application base, because in 5th grade, when they have that EOG, they're not going to have just straight vocabulary. It's not a vocabulary test. It is an application test. And that was a huge misconception that many teachers have, that, 5th grade science EOG is so easy. It's just as long as you know the academic vocabulary, you're fine. It's like, no, you have to apply it and understand what that vocabulary means. So if you are starting that all the way through kindergarten first, all the way through, then these kids will be set up for success in 5th grade when they have to take their EOG. Here are some of the best practices. One thing that I love to do with students, because they don't, one of the practices that I love to do with students is allow them to draw their prior knowledge. What did they think? What do you think is happening in this? Draw what a simple machine is for force and motion. That way, kind of gives them some freedom, also gives them some parameters, but they also can draw on their prior knowledge and take ownership. Next thing is an artifact. So using, let's say for solid, liquids, and gas, show them, display them, have them describe it. If you actually have something for them to tangibly touch, the engagement skyrockets. Then posing questions. So I'll show you in the lesson example that I start off the class with a question. There's many times in my class that students would ask me questions, and I would kind of turn it around and ask them probing questions, so they got to the finding themselves and they were actually taking ownership of their own learning. It wasn't like, oh, well, what do you think? No, that just frustrates a student. You have to ask them a question of, well, why do you think this? I'm trying to think of an example. Why do you think this would happen instead of this? Why do you think liquid takes up this sort of shape while a solid doesn't? And then they start to piece together. Another way is making a product. So if you are looking at making a simple machine. They are going to have different items. And I did where we had a whole bunch of different items out. So pipe cleaners, wooden popsicle sticks, straws, tape, paper, cups. And they had to pick 5 items and they had to create a simple machine. I didn't give them, oh, you need 1 cup, you need this, you need this. But they had to develop it based on their knowledge. Another thing is making a theory. Give them some resources about law of conservation and then say, why is this? And they have to come up with their own theory. And then the last one is analyzing graphs. This is a great one for force and motion because you have your distance time graphs already there and have them analyze it. Why do you think that the y-axis is much larger than the x-axis? So these are ways to engage the students. Now we're going to look at the NC standards. I know that you've probably already seen these, but I wanted you to truly understand what each little part means. So PS is physical science. So you'll see up here, this is a 4th grade example. So you'll see PS.4.1. So PS is physical science, 4 is 4th grade, and standard 1. So the standards and objectives, you'll look at the standards and then go straight to the objectives. I never really paid a whole lot of attention just to the standards, but you'll want the objectives. And some of these objectives will take you several days, sometimes several weeks. My 5th grade unit for weather took a month and a half, 2 months because of how much vocabulary and how in depth it was. So really understanding what these these letters and numbers mean. So here's an example. And I took this straight from a 4th grade PowerPoint. I loved PowerPoints, not just to read off of, but it gave us a guide throughout the day. So you would see like this picture, you would automatically think, oh, this is Earth and space. No, because we're talking about weight versus mass. I'm telling you that the students did not know that. This was on the board as soon as the kids came in. So I was like, think about, would you weigh the same at school or on the moon? And then I would have the kids discuss. And then they would share out, what did your partner say versus what did you say? And then I would ask them questions like, well, why do you think that way? And what evidence do you have? Then we got into the actual investigation. And I gave them little pom-pom balls, and they had to figure out these different items and how much they weighed to make it equal. Another good thing to do is to add in different vocabulary as much as you can. So if you will notice that I have quantity and then amount next to it. So I wanted to introduce quantity, and it's just an easy way to give them different vocabulary instead of just amount or number. So I had them working in groups. Not every student had a scale. So that's another big thing with science is working in groups and learning how to collaborate with others, not just your best friend or not individually. The next part was, here was the guiding questions that I would ask, and I would get them to talk to their group about these. And then if you'll notice, there's a little link down here. That's where I introduced the vocabulary of mass versus weight. I hadn't told them before. This is the first time I introduced it. So this is a very different way of thinking of how to plan your lesson, because oftentimes, like in math, you'll start, oh, we are talking about fractions, and we are adding fractions with unlike denominators. You kind of start the lesson that way. Science, you almost do it backwards. You want them engaged and them to almost find out their own theory and way. So, again, I did not talk about the vocabulary mass versus weight until I introduced that video. Then we talked about the actual vocabulary. We went over it. And then I gave them a simulator. And we kind of practiced and looked at mass for this. And then during COVID time, one of my best friend teachers, we made videos so they were actually able to see different examples of mass through experiments. And then I talked about weight and what does that mean. So now they're learning about it based on what their findings were with the experiment of testing different items. Then I had them conduct the experiment with actual weights. So before I had just the pom-pom balls, now I have actual weights. So again, it looks very similar. And then I have questions. I want them to make sure that they can answer these so that I really know that they understand and grasp the concept. Then to hit it home, we talk again about mass versus weight. So them understanding that it's not the same. Oftentimes those are interchanged, but they're not the same. So this week you are looking at physical science and creating a little activity that your students would do. Okay, you can choose the grade level and you can choose whatever component you want, but it has to be science. And your activity must be inquiry based. So use AI, use all that. But I want you to add in some different examples, or how would you change that lesson to be better? Because AI doesn't really think about inquiry based. They're used to just the routine lessons. So maybe it's adding in collaboration, because all throughout this, they were collaborating. We were asking questions. All of that. So if you have any questions, please feel free to email me. Thank you, and have a great day.